Hello everyone, in today's math challenge, we will talk about sharing of cookies. Okay, so there are 135 cookies to be shared among 16 children, and each child will get at least one cookie, so no one will leave barehanded. Also, to make it simple, no cookie will be broken into two or more pieces, so here we are talking about the sharing of the whole cookies. Now, can you prove that no matter how the cookies are shared, there must be two children getting the same number of them? So you can pause the video at this point and spend as much time as you need, and we come back for the answer. So this is another typical example for the reverse thinking. Just like many other questions, you will find it is far easier to work it out in the opposite direction. It is tricky to prove that at least two children will get the same number of cookies. However, we can view it from another angle. Let's see whether it is possible if all the children get a different number of cookies in this situation. Okay, let's start with the simplest case. So we have got 16 children, and we can give the first child one cookie, the second child two cookies, the third child three cookies, until the last child with 16 cookies. Okay, and then we just add all this number of cookies together to see how many we need in total. So if you want to add 1, 2, 3 until 15, 16, actually there is a very useful equation in the math we can use. Okay, so here we are talking about a series numbers from 1 to 3 to n minus 1 n. And if we want to add them together to calculate the sum of this series, we can use this equation. It's equal to the first value 1 plus the last value n in the brackets and multiply the total number of these values, which is equal to n, and then divided by 2. So you can quickly work out the sum of this series. So in this case, n is equal to 16. So 16 times 17 divided by 2 is equal to 136. So 136 is the minimum number of cookies required to satisfy this way of allocation to allow each child with a different number of cookies. However, we only have got 135 cookies, and this is impossible, and there must be two children with the same number of cookies. For example, if you allocate the first 14 children in our plan, and after the 14th child, we will only have 30 cookies left. So you have to either give the last two children 15 each, or you can give 14 to one and 16 to another, or 13 to one and 17 to another. So no matter what happens, you will see the child with lower number of cookies must have the same number with one of the first 14 children. Okay, so that means there must be two children with the same number of cookies. So this question just demonstrates the importance of reverse thinking skill in the mathematics. Okay, thank you very much.